Good morning. I am Dr. B. Vasugi, Assistant Professor, Department of Mathematics, Srmvec Engineering College. I am going to deliver the lecture for the course Discrete Mathematics. In this course, we are going to see the 5 units. What are they? They are logic and proofs, combinatorics, graph theory, algebraic structures, and lattices and Boolean algebra. First, we are going to see the first unit, logic and proofs. Under this, we are going to see propositional logic, propositional equivalences, normal forms, and rules of inference. So what is logic? Logic is the discipline which deals with the methods of reasoning. It provides rules and techniques for determining whether a given argument is valid or not. So logical reasoning is used in mathematics to prove theorem, and in computer science to verify the correctness of the program. In physical sciences, it will help to prove theorem. And also it is used to solve multitude problems in our everyday life. And logic is concerned with studying arguments and conclusions. There are two main components of logic. The first one is propositional logic, and the second one is predicate logic. Now we will see only propositional logic. What is propositional logic? The study of propositional logic, which consists of syntax, that is grammar, semantics, that is meaning, inference rules, and derivation. Propositional logic can be considered as a language of human reasoning. It consists of propositional variables which are denoted by the letters P, Q, or S, and so on. Propositional constants are denoted by capital T and capital F, which are denoting true and false. And also the connectives or basic logical operators, which are denoted by disjunction, conjunction, negation, conditional, and biconditional operators. What are propositions? Propositions are statements, that is, they are declarative sentences which are true or false but not both, and sentences which are exclamatory, interrogative, or imperative in nature are not considered as propositions. So examples, the first one, New Delhi is the capital city of India, which is a true statement. We can assign here true or false for this statement, therefore this is a proposition. How beautiful is Rose? That is the second statement. It is not considered as proposition because we can't assign true or false for this. Third one, 2 plus 3 equal to 3. It is a false statement. So we can take this also as a proposition. Fourth one is not considered as proposition, question type. And fifth one, what is the fifth one? It is neither true nor false, as the values of x and y are not assigned. So that this is also not a proposition. Take a cup of tea. This is not coming under proposition. If a proposition is false, we say that the truth value of that proposition is false, which is denoted by f or 0. If a proposition is true, then we say that the value of that proposition is true. It is denoted by capital T or 1. Primitive proposition, a proposition which is primitive or primary or atomic, if it cannot be broken into simpler proposition. In other words, primitive propositions do not contain logical connectives. Compound proposition, a proposition obtained by combining one or more propositions by means of logical connectives. Truth table, a table displaying the truth values of a compound statement in terms of its component part is called truth table. Logical connectives or logical operators. In logic, the letters P, Q, or S denote propositional variables. Variables can be replaced by proposition. Example, P, the proposition variable, it is taken the statement 2 plus 3 equal to 5. Another variable Q, it is taken as the statement, it is raining. So negation, disjunction, conjunction are called logical connectives or logical operators to form a new propositions. Negation. If P is a proposition, then the negation of P is the proposition, not P, and it is denoted by negation P or negation P. For example, if we take P, the proposition, as today is Monday, then What is the negation of this statement? That is negation P, which is today is not Monday. The truth table for the negation P, it will take two values, truth values. They are T, F. When if P takes T means then negation P will be what? F. And if P is F means the negation P will be T. Disjunction. If P and Q are two propositions, then the disjunction of P and Q is the compound proposition P or Q and is denoted by P or Q. The compound statement P or Q is false if both P and Q is false. Otherwise, it will be taking the truth value true. Then truth table for disjunction, that is shown in the table. So when both P and Q are true means true. If one is true, another is false means it will take true, and both are false means false. Conjunction. If P and Q are two propositions, then the conjunction of P and Q is the compound proposition P and Q and is denoted by P and Q. Then the compound statement P and Q is true if both P and Q is true. Otherwise, it will have the truth value false. The truth table is shown here. Conditional statement if then. If P and Q are propositions, then the compound statement if P then Q is called a conditional statement or implication and is denoted by P implies Q. In this implication, P is called the hypothesis and Q is called the conclusion. P implies Q is false if P is true and Q is false. In other cases, it will take the truth value true, T. The conditional statement P implies Q is read as P implies Q, P only if Q, P is sufficient for Q, Q if P. Truth table for conditional statement, already I have explained. So when second one is false and first one is true means the conditional statement will have the truth value F, otherwise it will take the truth value T. Then variations in conditional statements. If P and Q is the conditional statement, then Q implies P is called the converse of P implies Q. Negation P implies negation Q is called the inverse of P implies Q. Negation Q implies negation P is called the contrapositive of P implies Q. So some examples, write the contrapositive, we are going to write the contrapositive, converse and inverse of the implication. The conditional statement here is, if it is raining, then I get wet. So how to write the contrapositive? That is contrapositive is negation Q implies negation P. That means it if do not get wet, if I do not get wet, then it is not raining. Converse, Q implies P. If I get wet, then it is raining. Inverse, negation P implies negation Q, which is if it is not raining, then I do not get wet. Biconditional statement, if and only if P and Q are two propositions, then the compound statement P if and only if Q is called the biconditional statement, that is denoted by the notation. So P if and only if Q is true whenever P and Q have the same truth values and false in other cases. The truth table is shown here. T, T, T. When both are false means true. When both are true means true. In other two cases, it will have the truth value false. So now we are going to see some examples how to construct the truth table, how to construct the truth table for the compound proposition P or Q implies P and Q. First, what we need here, P, Q, P or Q, P and Q. So the truth values for each compound proposition. Already for P and Q we have 4 combinations. So for T, T, P or Q is T, P and Q, T. Then P implies P or Q implies P and Q will have the truth value T. So we have to use here the conditional statement. So second one false, third one false, fourth one is T. So for conditional statement, the second one is false. If the second one is false and the first one is true means it will take the truth value false. In all other cases, it will take the truth value t. So that here we have the option in second and third rows. So in the second and third rows, we have the option second false, first true. So another example, P implies Q implies Q implies P. The same thing, the columns are assigned for P, Q, P implies Q, Q implies P, then again conditional statement. So when second is false, first is true means true. When second is false, first is true means false. In other three cases, all the second one are T. Therefore, the truth values for the remaining three are T. So another example, PRQ, negation of PRQ and PRR. In a similar way, we can construct the truth table. So well-formed formulas, the statement formula in which the order of finding the truth values are indicated by using parentheses is called a well-formed formulas. Example, the first one, negation of here parenthesis is used. Negation of PRQ is a well-formed formula. And the second one, P implies Q and R is not a well-formed formula. So if you use parenthesis, then it will be a well-formed formula. So order of precedence of logical connectives. Negation precedes all other operators. Conjunction precedes disjunction. The implications conditional and biconditional have lower precedence. So, but among these two, conditional precedes biconditional. Tautology and contradiction. A statement formula which is always true irrespective of the truth values of the individual variables is called a tautology. A statement formula which is always false is called a contradiction. A statement which is neither a tautology nor a contradiction is called a contingency or satisfiable. Some of the examples are shown here. So S is equal to Q or P and negation Q or negation P and negation Q. So the truth table columns are assigned. So the final column is showing T for all the entries. For all the combinations, we have the truth value T, therefore it is a tautology. The given compound proposition is a tautology. So another example is shown. In a similar way, we can prove that the given compound proposition is a tautology. Third example, simple example. Here PRQ implies P. Here it is not a tautology. Here in the last column, that is PRQ implies P is taken as yes. The last column you have T, T, F, T. Here all the entries are not T, therefore we cannot say here this is a tautology. So this is a contingency, neither tautology nor contingency. Logical equivalence, two proposition P and Q are said to be logically equivalent if P if and only if Q is a tautology. Or we can denote this as P is equivalent to Q. So the symbol biconditional symbol is used instead of the equivalence. So P is equivalent to Q if and only if P and Q have the same truth values. So for proving whether the two compound propositions are equivalent, so we can check by using truth table. That is, if both have same truth values, mean we can conclude that the two compound propositions are equivalent. So let P and Q be two implication. Let P and Q be two compound proposition. If P implies Q is a tautology, then P is said to be logically imply Q and it is denoted by P implies Q. Show that the two propositions, compound propositions are logically equivalent. So we can take this into we can prove this by taking what truth table. So here both the P implies Q and negation P or Q have the same truth value, so that we can say both are logically equivalent, or we can prove P implies Q if and only if negation P or Q is equivalent to tautology. So another way of proving that they are equivalent. So here also The two statements are equivalent. Both have same truth values. So here the compound proposition is a tautology. So see the last column. So in the last column all are T, therefore it is a tautology. So how to write the statement in symbolic form? If Avinash is not in good mood or he is not busy, then he will go to New Delhi. So there are three statements. So take the first statement as P. Avinash is not in good mood. Second statement is he is not busy. Or for third statement, he will go to New Delhi. So the symbolic form of the given statement is P or Q implies or. If Avinash is not in good mood or he is not busy, then he will go to New Delhi. Implication is used. Negate the statement. John is playing football in two different forms. Form 1, John is, just to put a not, John is not playing football. In form 2, it is not true that it is not the case that John is playing football. So we can write either form. State the truth value of if tigers have wings, then the earth travels around the sun. So what is the truth value for this compound statements? You take the first statement as P. Tigers have wings, which is a false statement. Q. Earth travels around the sun, which is a true statement. So P implies Q. So recall the truth table. P implies Q. Second is false, first is true, means it will have the truth value false. Otherwise, it will take the truth value T. Here, second is a true statement, first one is false. Therefore, the truth value assigned here is true. Duality, the dual of a compound proposition that contains only the logical operators and, or, and negation is the proposition which is obtained by replacing each disjunction by conjunction, each conjunction by disjunction, each T by F, and each F by T, where T and F are special variables representing compound proposition which are tautologies and contradictions respectively. And what are the laws of propositional logic? The first law, idempotent law. So there are two forms, primal form and dual form. So P or P is equivalent to P, P and P is also equivalent to P. P or F is second law, identity law, P or F is equivalent to P, P and T is equivalent to P. Dominant law, P or T is equivalent to T, P and F is equivalent to F. P or negation P is equivalent to T, P and negation P is equivalent to F. Complement law, associative law, P or Q or R is equivalent to P or Q or R. Similarly for conjunction, commutative law, P or Q is equivalent to Q or P, and for conjunction, P and Q is equivalent to Q and P. Distributive law. Next, absorption law. De Morgan's law is important. Negation of P or Q is equivalent to negation P and negation Q. And in a similar way, negation of P and Q is equivalent to negation P or negation Q. Then double negation, negation of negation P is equivalent to P. Equivalences involving conditional. P implies Q is equivalent to negation P or Q. That is implication conversion law. That law is named as implication conversion law. P implies Q is equivalent to negation P. Q implies negation P, contrapositive. P implies Q and P implies R is equivalent to P implies Q and R. P implies R and Q implies R is equivalent to P or Q implies R. P implies Q and R. P implies R is equivalent to P or Q or R. P or R. P implies R or Q implies R is equivalent to P and Q implies R. These are very, very important laws. Equivalences involving conditional. P if and only if Q is equivalent to P implies Q and Q implies P. P if and only if Q is equivalent to negation P if and only if negation Q. P if and only if Q is equivalent to P and Q, or negation P and negation Q. And negation of P if and only if Q is equivalent to P if and only if negation Q. And we can use all the laws for proving the equivalence propositions without using truth table. So the first one, negation P implies Q implies R is equivalent to Q implies P or R. So take the left hand side, negation P implies Q implies R. that is equivalent to negation, that is the implication conversion law is applied here. P implies Q is equivalent to negation P or Q. Then in the second step, negation P. Negation P implies negation Q or R. Again applying the implication conversion law. Then third step, double negation. Negation of negation P is P or negation Q or R. Then fourth step, associative law is applied. Just interchange the bracket. Then fifth one, commutative law is applied in the first bracket. And then sixth step, associative law, again interchange the bracket. That implies again by implication conversion law, Q implies P or R. So we have got the right hand side proposition. Therefore, both given propositions are equivalent. So without using truth table, we can prove that the given two compound propositions are equivalent. We can verify whether the two propositions are, also we can verify the two propositions are equivalent or not. So second example in a similar way.